So today I'm just going to discuss a little bit around kind of how we train in regard to whether we should be focusing on skills or whether we should be focusing on sort of more nonlinear practices. So there's plenty of attention that's sort of going towards constraints-led approaches of training or nonlinear training. And it's kind of creating an argument of sort of skills versus nonlinear training or constraints-led approach. But I don't know whether it's an either or. It's definitely not an either or. There's a time and a place for both. So it's more about understanding which is the right approach at the right time rather than arguing which one you should do. So to kind of understand which approach you should take or when you should do which approach, you need to kind of understand how the transfer of training that you're doing is going to translate to operational performance. So ultimately what we're looking at is transfer of training to good operational outcomes. And that is in both skill acquisition, decision making, and all over or sort of complete performance or overall performance. So when it comes to understanding operational performance, we need to look at some of the sort of factors of human behaviors, threat-based behavior, sort of human factors type of thing. So when we consider operational environment, we need to look at it through complex theory or the lens of complex theory. If we think about it in terms of more of a complicated issue or environment, that's when we start to look at cause and effect relationships. So if I do this, it's going to equal that outcome, which is not really how it works. So I'm not going to go into these theories in any depth. This is more of a discussion to get you thinking a little bit more so that you can understand the operational environment that you're in and understand where your students are at, and then work out how you're going to apply the right principle, what that looks like in practice, okay, so you get the outcome that you're after. So if you look at it through complexity theory, it's more around how behaviors emerge based on all the factors that interrelate or combine within that environment to lead to that emergence. And then it's people understanding or the individual understanding what that behavior looks like or what those patterns within that complexity look like so they know what the right behavior is. So to do that, we need to prepare people for complexity, but we also need them to be able to execute skills within these complex environments, within high threat environments, in this sort of time constrained situation where there's very little time to identify what's going on, react, and then execute your motor skill effectively. So if we look at it through complexity theory, it gives us a little bit of a better understanding of the fact that we just need to give people a number of or enough exposures or variety of exposures that they can start to identify the right patterns. If we lock them into more of a complicated type of situation or use principles around sort of complicated environments, then we're just training them for relationships or cause and effect type of relationships. So they may see something that they think will result in a certain behavior, but it may not be correct. So there's chance for sort of misidentification or misapplication of use of force or behavior. So that's the first thing that we need to think about. And then it's understanding a little bit around how people perform in this sort of high pressure environment so that we can understand how we go about applying the right training approach. So when we look at it, again, this is not going to be a deep dive into threat-based behavior. It's more of a thinking exercise to get you thinking a little bit and moving away from this argumentative type of thing that we have where it's either or. So one of the leading causes of increase in threat response or stress response or anxiety, whatever term you want to use for it, is uncertainty. So it's uncertainty about the task or task uncertainty. It's outcome uncertainty, so they don't know whether they can get the outcome they want. And then it's uncertainty in their own ability. Okay, these are some of the biggest drivers of stress response or threat response. And these also impact their ability to regulate that response to within a reasonable performance level. So we want to get a little bit of a response because there's kind of an optimal performance area, but we don't want to breach that because then our performance sort of becomes suboptimal and anything can happen really. There's a whole heap of negative outcome effects on the other side of that. So uncertainty is a big driver of it, okay? And then it's kind of threat identification. So once they identify the threat, if they know how to deal with it, what it means, then there's less of a threat response and they'll perform a lot better. So the first thing that we want to look at is why do people underperform under these increased levels of heightened emotion? So there's a number of theories around it. So one of them is kind of more around the cognitive mechanism. So it looks at attentional control. So it looks at where we're paying attention to, whether we're focusing on the right things. And a lot of this has been researched through visual gaze behaviors where people are looking, where their attention is guided, okay? And then it's whether they can identify or recognize what that threat means to them. And they're shown that there's a big difference between experienced and novice performers as to when they're looking at the threat, how early they look at the threat, and how well that informs the corresponding action. So experienced performers are looking in the right places early. That's informing what's going on, and then they're choosing their use of force or their outcome or their behavior or how they're going to respond a lot earlier, which gives them time to execute the motor skill quite well. So within attentional control theory, there's that perceptual piece of trying to understand or sort of identify what it is that's going on and then comprehend what it means to them and predict their outcome. So if they're looking at the right information, they're going to be able to kind of arrive at the right decision. The other piece of that is within attentional control is that the visual system links to our motor system. So when we're executing a motor skill, there's some calibrations there in those final few phases or stages, and this is some of the quiet eye research that's looked into this, is they're calibrating those last final adjustments or minute adjustments in the motor skill to try and execute it accurately. So I'm talking a lot around firearms here in this instance. So it'll be those final few adjustments to get those sights where they need them to be so they can get that shot placement where they want to go. And this happens with a lot of different things. If they're not looking at where they need to, then that information they need to calibrate is missing. So they get a suboptimal outcome because they don't have that linkage between the visual information or the visual system and the motor control system. So that's kind of one of the theories around attentional control. And that's a little bit around perceptual motor performance. So another factor that plays into that is kind of the distraction model. And that works that they're being distracted by other information in the environment. So they may be looking at a threat, so they may be looking at something that they think is threatening, they may be over-fixated on a threat and they're not calibrating that final information, or they're not looking at where they need to execute that skill. Then one of the other theories that they sort of talk about is an execution focus. So this is kind of relates a little bit to working memory and procedural memory. So when there's a heightened level of threat, then there's a change in the activation levels within the cortices of the brain. So rather than kind of using our motor cortex and our sensory cortex and then retrieving the skill that we've already trained to a decent level from procedural memory where we've stored it, is that this increase of threat has increased activity within the sort of frontal cortex, which now we're starting to operate from working memory. So we're trying to execute a skill or retrieve that information from working memory rather than from procedural memory. So it's kind of a difference or a theory that even though we may have trained the skill to a high level, we're not recalling it or we're not retrieving it, how to do it from the right places. And our sensory and motor cortexes aren't functioning properly, so we get a poor execution of that skill. Okay, so there's kind of a few different theories around it. And then there's an integrated theory that looks at the impact of threat on both of those systems. So we've distracted, we're not looking at the right information or the right areas, and then we're not retrieving the skill from the right places. So this is kind of where we need to look at it, is that yes, we do need to be able to develop a skill to a high level. So you have to spend time, get the repetitions in, be able to develop a autonomous skill or as autonomous as you can so that it's stored in procedural memory. But then you also need to expose them to a representative threat from the environment that they're going to be operating in. So it's understanding the threats within your environment so that you're developing their ability to identify those threats, recognize what they mean, and then be able to perform within that level of threat, which is difficult within a training environment, as well as putting them in sort of scenario-based training or that constraints-led approach where you're using your constraints effectively so that you're developing their ability to understand complexity and identify those patterns early. So this is where it's more of integrated or combined approach rather than an either or, this way or that way. So we want to make sure, or we want to be able to identify what it is we're trying to teach at which particular time and what principle that we're actually going to apply so we get the right outcome. Okay, and then there's some other stuff around sort of embodied perception, its impact on the threat response or our ability to perform, which comes down to kind of a number of our physical abilities, our energy that we perceive we have, the energy cost of doing it, these sort of things, which impact it as well. So people that are sort of don't have the capacity to do the job to a high level or the physical ability, okay, they're going to have an increase in their threat response, which is going to lead to a change in their behavioral state, a change in these cognitive functions, okay? And it's also going to change the way they select the available options. So they may come up with an inappropriate response just because they don't perceive they have the capacity to respond in the most effective way, or what would be deemed more appropriate. Okay, and that's around sort of a number of their physical perceptions and the perception of their competence. So again, if you develop a skill to a really high level, there's a high perceived competence in your ability to do it, and that removes some of that outcome uncertainty and task uncertainty. So it allows them to be a little bit more confident, reduces the threat response, and allows them to focus on the right information. And if we are going to add a sort of representative threat within the environment, because we want to sort of have, contextual tolerance or tolerance for what they're actually going to be working under, or tolerance for the environment, we want to make sure that it's the right level of threat or it's the right stress. So different threats are processed in different parts of the brain. So if you've just got an abusive instructor that's yelling at somebody, that's processed in a completely different part of the brain than a physical threat that they're likely to see on the street or within their operational environment. So we want to make sure that we have the right threats so that they can learn how to perform underneath them, and there's less of that sort of transition into the frontal lobe. There's less chance that they're going to change the way these cortices are working with each other, because sort of different lobes or different cortexes of the brain inhibit activation with others. So we want them to be able to develop the ability to perform under that level of stress. So essentially we want to make sure that we've put the right cognitive load on them, and the load is suitable to them, and then we can progress it in complexity as they go. And this is kind of where some of the issues around a constraints-led approach is that within the research, a lot of these things aren't really well defined. So there's a lot of risk of misinterpretation for when people are applying constraints-led approach, that they could be doing anything, okay, without really understanding the principles of it. So when you start looking at other research around it, like cognitive load, differential learning, interference effect, a number of these sort of things, you can start to understand what this picture might look like and how you structure your training in the most effective method that you can to get the right outcomes. And you're putting the right amount of challenge, the right amount of cognitive load on recruits or students early in that piece, so that they're not being overwhelmed. So they're learning to perform under these cognitive loads, because training should be challenging to a reasonable degree. So this is quite a large space, and like I said, I'm not going to take a deep dive into it. It's more of just a discussion to get people thinking a little bit around how they develop their training effectively, and making sure they're not going down some random garden path which is going to lead to sort of suboptimal outcomes. So there's probably a lot more that could be said on this. This is more just to get people thinking about some of the other factors that need to be in there, okay, so that you're sort of designing your training as best you can, okay? And one of the other things with the constraints-led approach as well is that a lot of it comes from sports background or sports research, where if you're doing small-sided games or a constraints-led approach with kids in soccer, let's say, is that most of them can run, hop, skip, jump, kick the ball. So they turn up with the prerequisite motor skills to begin with, where if you've got new people and you're trying to demonstrate physical arrest skills, is they don't have, or they're unlikely or less likely to have that base level knowledge. So you can't just throw them into a constraints-led approach straight away and expect them to be able to solve every solution, because they don't know the actual motor pattern or the fundamentals of that motor pattern. So it's going to increase the cognitive load and potentially exceed their ability to do it. Okay, there's no reason why you can't give them a go, let them try and work it out, because we do learn more from failure than we do from success, as it turns out. So not getting the outcome once will put them in a situation where now you can stack the right outcome on them, and they're more likely to retain that information for future performances or for future lessons. So there are ways of going about this, where if we understand the principles of what we're trying to do, we can set up our training as effectively as we can, and we can get the outcomes that we want. So like I said, not an in-depth discussion. It's more just to get people thinking. Okay, if you have any questions, please reach out. Otherwise, appreciate your time, and I hope you got something out of that.